Assalamu alaikum wa rahmatullahi wa barakatuh. Well, we're gonna have lecture 2 of System Analysis and Design, chapter 7, Structuring System Requirement. And now we're still talking about the process logicing. So we are going to finish the DFD, the rules, and whatever left from the contents of DFD, balancing, and how you use DFD as analysis tool. Then after that, this is the lecture for whatever we have left in DFD, and then the next lecture hopefully it will be the logic modeling. Again, we are in the process modeling. We are in the phase, the analysis phase, after we collect requirement and requirement termination, requirement elicitation and gathering. We are in the chapter of requirement structuring and in the process modeling. After we finish the process modeling, we'll go to the logic modeling. Then after that, we'll go to the data conceptual modeling, the ERT. By that time, we can finish the analysis phase, and then we go to the design, then implementation, and by that time we finish the project. Okay, functional decomposition. What is really decomposition? Decomposition is to specify what a high-level process does and break it down into a smaller units in more DFDs. We go from the context diagram to level 0, and each of those in level 0 we could, if they are explodable, if they are decomposable, we could go and decompose them again to level 1. And we do the same thing that all the entities in level 1 and then level 2 until we reach the primitive DFD, the N-level DFD, which it is the lowest level of the decomposition. So each high-level process is decomposed into other processes with data flows and data stores. And each decomposition is a DFD itself. And it is an iterative process of breaking system description down into a finer and finer detail. It creates a set of charts in which one process on a given chart is explained in a greater detail on another chart, which it is the one which is the explodable one. We detail it and detail until we reach the N level, the last DFD, the primitive DFD we call it. Continues until no sub-process can logically be broken down any further. As we just explained a few seconds ago, the primitive DFD is the lowest level of DFD. Level 1 diagram result from decomposition of level 0. Level 2 is a result from decomposition of level 1, and so forth, until we reach level N program, which is the lowest level, is a DFD diagram that is the result of N nested decomposition from a process and a level 0 diagram. Okay, if we take the entity on level 0 diagram for the restaurant system, for the food ordering system, number 4. Number 4, it has one input, which it is the daily goods sold account and the daily inventory. If we go back to that one, we could find that there are two inputs. One of them, the inventory file or parameter, and the other one, it is the goods sold file, which it is المبيعات والماتيريال الموجودة، الانفنتوري الموجودة عندنا. That 4.0, which it is the entity existing in level 0, we explode it, we decompose it to 3 entities here, 4.1, 4.2, 4.3. And there is output, there is one output, which it is management report. So the first one is the excess goods sold. You send the inventory and you send the goods sold, aggregate goods sold and inventory data, and then prepare management report is 4.3. If we look at the two arrows, the daily inventory and the daily goods sold, those that are the N. So still the same as in level 0. And there is one out, which is the management report. So in this case, we could say that it is a balance. So we have two input and one output. Okay, let's look at the 4.3 entity or process, which it is in the previous diagram. It has one input, the aggregate data, and one output, the management report. That one we decompose it to 4.31 and 4.32. If you look at, those numbers, you could say that the 4.31, it is the first entity in this level, which it is, it could be level 1 here, and level 2, and it's from 3, which it is in level 1, and 4 is from level 0, which it is, it comes, to level 0, then level 1, then level 2. Aggregate data is the input and management report is the output. So every time we go to the nested DFD, we find, first thing we find if it is balanced or not. Balanced or not, this means it's the number of input and the number of output they leave that process are the same in the two levels. Again, as we did explain what really balancing is, conservative principle, which is conserve input and output to a process at the next level of decomposition. Balancing, conservation of input and output to a data flow diagram process when the process is decomposed at a lower level. As we did explain before, what balance means. Balance means a number of input to a lower level DFD equals number of input to the associated process of a higher level DFD. Like the one in level 1 DFD, it is the same as in that entity. For that entity, the one we decompose it in level 1, the one it comes from level 0. Number of output to a lower level DFD equals number of output to associated process of a higher level DFD. Okay, let's look at this one, which it's unbalanced. There is a context diagram there, which it has a source, which is the A, and B is the sink. When we go to level 0, we explode context diagram to two entities, 1, 0 and 2, 0. And if you look at how many input it goes to 1, 0, there are two of them. It's source 1 and source 2, which is A and C. But the sink 1, it is just one sink, which it is the B, which it is we don't have a problem in the sink, but we have a problem with the input. So this is unbalanced because the process of the context diagram has only one input, but the level 0 diagram down there, you see two inputs. If we look at balancing DFD, when we split the data flow, data flow, which means that when a composite data flow, a data flow has two different parameters which it goes to the same process at a higher level. It's splitting and different parts go to different process in the lower level DFD. The DFD remains balanced because the same data is involved but split into two different parts, as we are going to see in the next slide. If we look at this, it's a balance. You have a composite data flow in A, payment and the coupon. Payment and the coupon, we split it to payment or coupon. It is the same thing. It has the same parameter. It goes to a part of the process. One of them go to X1, one of them go to X2. And this is, I believe, it is the example of this one usually in the grocery store. When some store take the coupon especially the one, you know, like the welfare. This is for food only. And the other items, which it is, you can pay. So the same cash register, the same process, has two sub-processes there. If the item, it is a Cuban item, which it is under the food welfare, it's given free for the customer, or it is, you know, use the Cuban instead of the money. You could use the same parameter in the payment or the Cuban, and the cash register will split them. If it is a payment, or they charge you for it $1, and the other one they take a Cuban from you. Well, this slide, it will govern some of the rules, advanced rule for data flow diagramming, as we said, you know, earlier. Like in the composite data flow, you could split it into components data flows at the next level. The input to the process must be sufficient to produce the output. At the lowest level of DFD, a new DFD may be added to represent data that are transmitted. And the last thing, to avoid having data flow cross each other and make it so cluttered, you could repeat source or sink or a data store in the same data flow in two places, but you have to have the same name for them, and the parameter and the data flow, it goes to them, it should be the same. As we said earlier, you know, there are 4 different types of DFD, but actually they are not different types. It is 4 different diagrams we could really draw for any project, whatever. The current physical, which represent the processes, and we identify technology and people or system, you know, use that process. So we put the people, the person who is really accomplishing that process or whatever it is. Then data flow and data store identify actual name of the physical media. But the current logical, we remove the physical thing and we put a name of a process or a name of the person who is doing that process. No, not the name of the person, the name, we put the process instead of the name which it is exists in the current physical. Then after that, after we have the old physical and then the old logical, then we change some of the function. We remove some of them. If they are obsolete function are removed. Include additional function. We could add more function to the system. And inefficient data flows are reorganized. If there are some data flows, if there are some data sets, anything we need to change, we change it and we come up with the new logical. The current physical and the current logical, they represent the existing system. The new logical, it present the new system we are going to have. Then after we finish the new logical, we go to the new physical, we represent the physical implementation of the new system. Now, there are some guidelines for drawing DFD, which it is easy actually, it's not really a big deal. It should be complete. The drawing DFD, it should be complete. DFD must include all components necessary for a system, where each component must be fully described in the project dictionary or case repository or rational unified process, rational rows. Anyway, it should be documented. That's what really I mean here. The other one is consistency. Consistency, I think it should be consistent. The extent to which information contains and the one level of a set of nested DFD is also included in the other one. Right, in the second or the lower level we explode it, but actually it's still be represented in the second, in the lower level. Okay, again, one of the guidelines or feature of DFD, it's not represented well. The timing is really not presented well in DFD, which it is not really a big deal because really this is a process modeling. And when you see a process comes after that, like there is a process and then another process comes after it, this does not mean that the first process is really run first and then the other one runs after it. Best to draw DFD as if the system has never started and will never stop. I mean, there is no sequential activity. This does not mean that this process runs, then the other one comes, they come in sequence. No, it's they are independent. Then one of the guidelines, it is an iterative development. Analysts should expect to redraw diagrams several times before reaching the closest approximation to the system being modeled. Of course, we're going to do it iteratively, because the more we get more information, the more we kind of redesign or try to find out some of the functionality of this process. It has to be in the other process or whatever. So we have to do it again and again and again. So we are going and doing it iteratively. Last guideline saying or feature or whatever, it's separative DFD, which is the lowest level, which is the N level DFD, the lowest logical level of the decomposition. Decision has to be made when to stop decomposition. That's the problem here. Where we're going to stop, decomposing the DFD. Sometimes, in level 0, 1 or 2 entities, probably this is the lowest level for them. That's it. They are not explodable. They are just a small program or function we write. And then we take the rest of the one in level 0 and then we go explode each of them to level 1. When we go to level 1, probably in one of them we could find another 2 or 3. They reach the primitive DFD, which is the lowest level. So we stop explosion at least for those. But the one it's more explodable, we just keep taking it and to level 2, to level 3, to level 4 until we reach the primitive DFD, which it is the lowest level. The question now is, where we're gonna stop? Where we're gonna stop, I think it is your decision as system analyst. You could stop when there is a program there and there is a reason for stop the program or small, it doesn't have many function. But if it has many function, then you go to another level, to a lower level, and you have the external function in the level after that program. But it is really your choice. Well, the coming 3 slides, it lists the guideline for stopping decomposition. The way I see it, stop decomposition, it is really your decision, which it depends, on the environment. It depends on the non-functional requirement. Let's say that one of them. If one of the non-functional requirement, which it is very important, the system should be easy to maintain. Should be easy to maintain. This means you have to have a very small component, very small program, which it means you need to explode it further. And this means you need to go to a second or third or fourth level. But if you want to have the system, fast, this means your component, it has to be large to fulfill all the functionality without any need to go and call another component or a third component, whatever. Which it means that you don't need to go further to another level. So it is really your decision. So for this slide and the other 2 slides, there are some rules. Like in this slide, if you read it, when each process has been reduced to a single decision, calculation or database operation, when each data store represents data about single entity. So we just read them quick and we go through these slides. Again, when the system user does not care to see any more detail, when every data flow does not need to be split further to show that data are handled in a various way. When you believe that you have shown each business form or transaction online, display and report as a single data flow, when you believe that there is a separate process for each choice and all lowest level menu option. See, the way you see it, it is really kind of up to you, which it is really, it depends on the environment of your project. Well, if you look at DFD, I think it is, you can really use it as analysis tool in 3 different ways. First of all, the gap analysis, which is the difference to find the discrepancies between 2 sets of the DFD in 2 different levels or in 1 level, in the same level. The second one, inefficiency. It's easy for you to look at one model and find out if there is a data set really created and it never be used in all set of DFD. And the third one is comparison of DFD's current logical with a new logical and determine which process should be added or revised. Well, if we look at this screen or this slide using DFD in business process reengineering. Well, this represents, an IBM Credit Corporation primary work process before the business process reengineering. If we look at, the process there and the data store there, we have a data store interest file and we have a credit file. Those stay the same, We have a salesperson and the salesperson. Look at the salesperson down, the one that goes, there is the contract. He received the contract from create the letter, from 5.0. This one is one of the rules we put, when we said repeat it again, you could repeat it. The salesperson up there and there is another salesperson down there. They repeat it. It is the same source and sink. Here it's sink, and in 1.0 it is a source, and in 5.0 it represents a sink. They use it at, because it is so cluttered. There is a lot of data set and processes, whatever, to use it there for. But if we look at the slide after, they add a new source or sink, whatever, which it is a specialist. And they leave the thing, because, they work and the process, they change it, using the business process reengineering. It's easy for them to look at the DFD and see what's going on in all activity there, and they try to change it. They could really get rid of some of these processes, they could. But anyway, we look at the slide after and we see what's the outcome of the business process reengineering and their decision on it. Okay, if we see the output, for the business process engineering, which is IBM Credit Corporation primary work process after the business process reengineering. You look at the salesperson, it work here as a source and sink. The process contract, it is inside, they change whatever they change. The credit file is still as an input, and the interest file again it is. And they add one there, which it is the specialist, which it is having a supporting data to it there. By this slide, we finished chapter, we didn't finish the chapter, but we finished the process modeling. By that, we finish lecture 2, and lecture 3, hopefully it will be the logic modeling. The process modeling is done, the logic modeling, which it is, we'll see it soon. Thanks.